Okay, so let's have a look at some more questions from the 2022 HSC Advanced Maths paper. So we're going to start with question 6. So what is this integral? Alright, well, immediately looking at this integral, it's not C or D. Whenever you differentiate a log, it becomes the derivative of the thing inside the log over the thing inside the log. 1 over x squared is not derivative over function. So it's not a log. So we can just differentiate a and b, and we can see what we get. So we'll try a first. We have minus 2 times 2x plus 1 to the minus 1 plus c. So if we differentiate this, we will get the minus 1 comes down the front. It'll give us 2 times 2x plus 1 to the minus 2 multiplied by the derivative of the inside, which is 2. The c goes away. So this will be 4 over 2x plus 1 squared. So this is not right. So it's not a. We'll now differentiate b. This will give us minus 1/2 2x plus 1 to the minus 1 plus c. You could at this point infer that the answer must be b, but we'll calculate it anyway. We get 1/2 times 2x plus 1 to the minus 2 multiplied by the derivative of the inside. The 2 and the half cancel. This gives us 1 over 2x plus 1 squared, and this is the answer. So therefore, what's the integral? The integral must be b, and b is in fact the correct answer. So let's have a look at question 7. So we have, consider the following graph of a probability density function. What is the value of the mode? So we need to find the mode in this case. So mode. Now if you remember mode is most common. Most common. So this will correspond to the highest point on this function, because this is a probability density function. It's telling you the probability at each x value of that x value being selected from a data set. So the highest point is the point pi on 4, 3 on 2 pi. So therefore the mode has to be the x coordinate of that point, which is pi on 4. And so the answer is C. And this is in fact the correct answer. So let's have a look at 8. Question 8. So we've got the graph of the even function, y equals f of x is shown. The area of the shaded region is 1/2. So the area of the shaded region A is 1/2, and the area of the shaded region B is 3/2. What is the integral from minus 2 to 2 of the function? Okay, so this looks like an integrals question. It's not. We don't need to do this as an integral. The function sort of comes down here, goes up here, goes back up, goes down, and comes back up. Sort of looks like this. This we know is 3/2. This we know is 3/2. This we know is 1/2. This we know is 1/2. Now when we take an integral, the integral will count these areas as positives and these areas as negatives. So the integral from minus 2 to 2 of the function will be the areas between the function and the x-axis, with the condition that any areas between the function and the x-axis which lie below the x-axis will be negative. So the ones below the axis will come in as negative when you do the integral, the ones above will come in as positive. So if it says what is the area is not the same as the integral in this case. So we have minus 3 on 2 plus 1/2 plus 1/2 minus 3 on 2. So minus 3 on 2 plus 1/2, that's minus 1. So both of these are minus 1. So this is minus 2. Therefore the answer must be C. And C is indeed the correct answer. So now let's have a look at question 9. So question 9. We're told Liam is playing 2 games. He is equally likely to win each game. The probability that he will win at least one of the games is 80%. Which of the following is closest to the probability that Liam will win both games? Okay, so at least one is 80%. So at least one is 80%. Now when we're doing at least one, the probability of at least one from two games is 1 minus the probability that he loses both. Now we know the probability that he wins at least one, which is him winning the first one, him winning the second one, or him winning both. This is 80%. So this gives us 0.8 is equal to 1 minus the probability of him losing both. We minus 1 from both sides, multiply both sides by minus 1. This gives us the probability of him losing both is 20%, 0.2. And because if you draw a tree diagram here, he can either win or lose. So this is win, this is lose, and then he can either win or lose, win or lose. Losing both is this end probability down here. It's 0.2, and this means it must be probability of lose times probability of lose. So if we want to find the probability of losing any given game, we can just take the square root of 0.2. So the probability of losing one game is the square root of 0.2, because two lots of this have to be multiplied together to get the 0.2. So square root of 0.2, that is the probability of him losing given game is 0.44721 ... Now the probability of him winning a game is 1 minus the probability of him losing. 1 minus the square root of 0.2. And the probability of him winning both is probability of winning multiplied by probability of winning. So probability win both is 1 minus the square root of 0.2 multiplied by 1 minus the square root of 0.2. Now because we want a decimal approximation, we can just put this straight into the calculator. It's going to be 1 minus square root 0.2. It actually doesn't matter if you put in the decimal approximation or the square root of 2, because they're just asking you to approximate this anyway. So this is 0.3055 ... So which one is closest? The answer is A. 31% is the closest percentage out of the percentages listed. So this had a little bit of working in it, but it's not too bad. You can sort of reverse engineer the question from the information you've been given, then calculate the percentage. That's it. There are some other methods to do these questions that are quicker. I like the reverse engineering style methods where you actually take the information, find all of the information from that, because that can often be done. So the last question in this set is question 10. Now we are told these graphing questions are somewhat unusual. We are told the graphs of y equals f of x and y equals g of x are shown. Which graph best represents y equals g of f of x? So the way we can do this is we can draw y equals g of f of x by evaluating a few points, connecting the dots, and then we'll see which one of these is most likely to be valid. So first, we have g of f of x. So if f of x is, if x is 0, f of x is 0. If g is 0, then we get y is 0. So we know it passes through the origin. They all pass through the origin, so that's not hugely helpful. Let's have a look at what happens when x goes to infinity. When x goes to infinity for f of x goes to infinity. When f of x goes to infinity, g of f of x goes to 0. So we know it approaches 0 as it heads out to positive infinity. This is convenient because it means d is not possible. So we can already discount d. And we know that it goes out to infinity from above. Now let's look at what happens as it goes to negative infinity. As x goes to negative infinity, f of x goes to positive infinity. As g of f of x, as f of x goes to positive infinity, g, the x value inside the g function, goes to positive infinity. That also goes to 0, but now this way. So we know that it can't be d. We're fairly sure that it can't be c either. So it's not going to be d, it's not going to be c, it's not going to be a, so we're pretty certain that it's going to be b. We need to be a little bit careful in assuming this, right? B is our sort of assumed answer. If you're in an exam and you try and get through it really quickly, it's probably okay to just say it's unlikely to be C, B is going to be the correct answer. When we evaluate this, as f of x goes to infinity, g of x goes to 0, and g of x goes to 0 smoothly. So C sort of bends down and then goes up, so it doesn't look like it's going to 0. It looks like it's going up to some value. Whereas the g of x function, sorry, we shouldn't say g of x is going to 0. G of x is flattening out, right? C of x is flattening, but it's going up. That's not really what we expect to be happening in this function.